Click the bell icon to get latest videos from Ekeeda.
Hello students, and today we are going to study a numerical which is based on inverse Z transform signals having simple pole, multiple pole and repeated poles, and also their ROC. Problem number 3 that we are going to study right now. Now in last two videos we have studied a numerical which is based on simple pole and multiple pole. Now the current numerical is based on simple pole, multiple pole as well as repeated poles. So first of all we'll see the question and then we'll move on to solution. Problem number 3. Obtain the inverse Z transform signal and it is given by x of z equal to 1 upon z minus 1 z minus 3 the whole square. Basically look at here. If we don't have a square in this question, then our question is simple pole and multiple pole. It is based on a simple pole and multiple pole. But right now we have a square in z minus 3, or you can say that the power of z minus 3 is 2, which means it is also a repeated pole. It is the example of repeated pole. So right now we are solving a numerical which is based on simple, multiple and repeated. Simple means here the order of a pole is 1. So z minus 1 is having power 1. Now repeated means here the order of poles is greater than 1, that is 2. Here z minus 3 is having power 2, and multiple means we have a number of poles in denominator. Now first of all we will go for solution, that is we will calculate or we will solve the inverse Z transform using a partial fraction first. Now we are going to find out the inverse Z transform of this function, but before moving to that we don't have any Z in the numerator. So of course what I am going to do, first of all I can say that just multiply numerator and denominator by Z and then shift this Z on left hand side, or else simply you can say that just divide both the sides by Z. So if I divide both the sides by z, then x of z will be replaced by. If we divide both the sides by z, then x of z is replaced by x of z by z, and we'll multiply this denominator by z. Right now, look at here. How many poles we have in the denominator? 1, 2, and here the order is 2, which means total is 4. So we'll use 4 variables. And this is nothing but my equation number 1. Just do one thing, cross multiply this denominator, or you can say simply multiply this denominator on the right hand side. Now after multiplying I have got this equation, and let's say this is nothing but equation number 2. Now what we are going to do, I am going to substitute the value of z such that you will get the value or you will be the answer. Now I am going to substitute the value of z so that you will get the answer of A, B, C, D respectively. So first of all I will put z equals to 0, or simply if I want to get or if I want to calculate value of A, then just equate this denominator of A equal to 0. What you will get? Z equals to 0. So all these terms which is carries a z term, or if now we are going to put z equals 0 in equation number 2. Just look at here, in B, in C and in D, in all these 3 terms we have a z value, and if that z is replaced by 0, then whole product will give us a value 0. So we will get only the value of A. As the z is replaced by 0, then we have only minus 1 in bracket. Then if the z is replaced by 0, then we have minus 3 in bracket, and the next terms are 0. Now minus 3 square is 9, but 9 into minus 1 is minus 9. And if I shift this 9 on left hand side, what you will get? Minus 1 by 9. Similarly we will calculate value of B, C and D. Now what we are going to do, we have to calculate value of B. Now look at it, which term is missing over here? That z minus 1 term is missing over here. Substitute z equals to 1 in whole equation. what you will get? This A term will get vanished. Similarly, as well as C and D will also get vanished because this Z is replaced by 1. So 1 minus 1 will give us 0, and 0 into whole thing is 0. Here also this C will also changes to 0 and D will gives us a 0. So what we have? This whole A is replaced by 0. Now next, what we are going to do? Z is replaced by 1. So here I have written 1. Now 1 minus 3 is minus 2, and minus 2 square is plus 4, and the rest of the part is 0. Now look at here, 4 into 1 is 4. So we have a 4b equals to 1. Just shift this 4 on right hand side. What you will get? The b value will be 1 by 4. Now we will calculate the value of c. So how will you get the value of c? Simply, which term is missing over here? Of course, z minus 3. So substitute z equals to 3, so that all the z minus 3 terms will give us a value 0. So look at here. If this z is replaced by 3, then 3 minus 3 will give us 0. So whole A becomes 0. Now look at here. This B will also changes to 0. This D will also changes to 0. Only C term will give us answer. So 3 minus 1 is 2, and 2 3s are, you will get 6. So on right hand side we have a 6C, and the left hand side we have 1, but I have changed the place. Now shift this 6 on right hand side. What you will get? Our C will be nothing but 1 by 6. Now we will move on to D. But how to calculate value of D? Because we already have substituted Z equals to 0. If I substitute Z equals to 0, then whole D will get vanished. If I substitute Z equals to 1, then D will get vanished. If I substitute Z equals to 3, then also D will get vanished. Now tell me which term you are going to substitute so that you will get a value of D. So we will substitute a different letter or different number. Let's say a minus 1. So what you will get? All this Z will be replaced by a minus. So look at here. Minus 1, answer is minus 2. Similarly, minus 1, minus 3, answer is minus 4, a whole square. Here also BZ, so this Z is replaced by minus 1. Now this Z is also replaced by minus 1, so we have minus 1, minus 3, minus 4, and that will be square. This Z is replaced by minus 1, this one also replaced by minus 1, so minus 1, minus 1 will give us minus 2. Now in the last, minus 1, minus 1, minus 2, and minus 1, minus 3, minus 4. Now simply do the multiplication. Now minus 4 square is 16, but 16 to the 32. So we have minus 32a. Now move on to b. Minus 4 square is 16, but 16 into minus is nothing but minus 16 into b will get minus 16b. Now minus 2 into minus 1, answer is plus 2. So we have a 2c. And at the end, minus 4 into minus 2 into minus 1, answer is minus 8 into d is minus 8d. Now look at here. Just shift this minus 8d on left hand side and 1 on right hand side. Now I'm going to substitute the value of a, b and c over here. Now I have substituted the value of a, b and c in this equation. Now minus 32 into minus 1 by 9, answer is plus 32 by 9. Minus 16 by 4, answer is minus 4, because we can divide the 16 by 4 also. Now look at here, 2 by 6 is nothing but 1 by 3, and at the end we have 1, and this is nothing but 8d. Now just do one thing. We'll add all these values and then I'll divide it by 8. So I have added all these values and what I have got minus 10 by 9 as a result, and we have 8d on the left hand side. Just shift this 8 on right hand side. What you will get? Now if we divide these two numbers by 2, then there will have 5 and here we will have 4. So our answer for D is, now we'll substitute values of a, b, c, d in my equation number 1. Now look at here, I have already substituted the values of a, b, c, d in my equation number 1. Now just multiply z on right hand side. So if we multiply this z with the first part, then z it cancel, we have only minus 1 by 9. Now I'll take this 1 by 4 constant, I'll take it outside. So what we have after multiplying with z with the rest of the part, we will get z upon z minus 1. Similarly, I'll write constant part first. Then after multiplying z, what you will get? Z upon z minus 3 the whole square. And at the last, minus 5 by 36, I'll take constant. And z minus z by 3 will be there. Now apply inverse z transform on both these sides, because our result in the form of z upon z minus e. So after applying, what you can say that inverse z transform of x of z is nothing but x of n. Now as minus 1 by 9 is constant, so we have only 1 over there, and the inverse z transform of 1 is nothing but del of n. So I can write 1 by 9 into del of n. Next, 1 by 4 is a constant, but z upon z minus 1 inverse transform is u of n. Now look at here. Here we have z upon z minus 3 the whole square. Now look at here, our a value is 3, so I can write 3 raised to n. Now if this 3 is removed, then z upon z minus 1 we have, and the whole square is there, so it is nothing but the n into u of n. The inverse is n into u of n, and the last, that is minus 5 by 36. What we can say? Here we have z upon z minus 3. Now this is, both the terms are simple and same, only thing is here the order is increased by 1, because we are multiplying u of n by n, or you can say because of differentiation property. But right now here we don't have any n, so the result is 3 raised to n into u of n. And this is nothing but the inverse z transform of x of n. Now the similar type of questions may be asked in exams, or it is totally depends on inverse z transform. Now in these 3 questions, what we have studied, how to find out the inverse z transform of simple poles, or we can say that how to find out inverse z transform of signals when we have a simple pole, multiple pole and repeated poles. Now in next 3 numericals, we are going to find out the ROC of the same, or we can say that inverse z transform but using ROC. So for that, stay tuned with Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.